Welcome to another video at askmath.com. Let's read the directions of this problem. Find the y-coordinate of the point of intersection from the lines produced by the equations, given 6x minus 4 equals negative 5y minus 1, and negative 3x equals 2y. Let's remind ourselves of what we're being asked to find. We're being asked to find the y-coordinate of the point of intersection from the lines produced by the equations. Anytime you have an equation with two variables like an x or a y, and there's no math other than addition, subtraction, multiplication, division in the equation, so there's no exponents, for example, that equation, if you were to graph it, would make a straight line on a graph. We don't know exactly what it would look like yet, but we know that it's going to be a straight line. We have two equations, so we know that there's going to be two straight lines. So either the other straight line will intersect the first line at a point, or it is possible also that you could have two lines that are parallel, they never cross, or it is also possible that you could have one line on top of another line and they would cross at every point. We're being asked for this middle scenario here where there is a point of intersection. And remember that any point on a graph has coordinates in the format x comma y. We're being asked for the second coordinate, the y-coordinate. Now we could graph this if we had some graph paper, but we don't. And also graphing is really usually used just for understanding what something looks like. It's not really used for functional purposes. If you accidentally make a little mistake, or you don't have a ruler, or your hand is shaking a little bit, you could come up with the wrong answer. So computers, for a lot of different reasons, will use equations, and they can compute things using equations. They don't actually graph and visualize it. So it's an important skill for us to be able to tell computers what the correct equations are and the solutions to those equations. And that's one application of where this math is used in the real world. Okay, so we're not going to graph it. Another method is called substitution, and substitution works best if on one side of the equal sign in either this equation or the other equation, if on one side there's just a variable all by itself, like a y or an x, and we don't really have a variable all by itself. We've got a 2y or a negative 3x, for example, and up here it's even worse. We've got 6x minus 4 and negative 5y minus 1. So substitution's not probably going to be the easiest method. Instead, we're going to try to use a method called combination. And combination just means adding together expressions. Whatever expressions you can add together, we will add together, and those are called like terms. In other words, expressions like 6x, positive 6x, and negative 3x, those both have x's, so those can be combined or added together. So what our goal is right now we've got an x and a y in each equation. You can't solve an equation when it has two variables in it. So our goal is to combine these equations and do it in a way that gets rid of either the x's or the y's. So I see that the 6x and the negative 3x, if I could just change that negative 3x by making it twice as big, 2 times negative 3x would make a negative 6x. That's the exact opposite of this positive 6x, and if I added those together, it would get rid of all the x's. It would make 0, and the x's would be gone, they'd disappear. I can't really do that with the y's, because like if I just multiplied 2y times 2, I'd have 4y, or if I multiplied 2y by 3, I'd get 6y. Neither of those combines with negative 5y to make 0. So we'd have to use decimals or fractions. I'm going to try not to do that if possible. So what I'm going to do is I'm going to just take this second equation, and I want to make that negative 3x twice as big, and that means that I'm going to multiply it by 2. But whatever I do to one side of the equation, I have to do to the other side of the equation. So I'm going to multiply it by 2 as well. So 2 times negative 3x makes a negative 6x, and 2 times 2y makes 4y. So now I've taken the second equation and I've doubled it. I've made it twice as big. Okay, so now I'm going to take the first equation, just write it below this one so I can have them close together when I'm working on it. Now notice I kept my equal signs lined up. I lined up the x's. The negative 4 in the top equation there doesn't have any term like it in this equation that we created here, so it's just blank right there. I've lined up the y's on the right side, and then same thing with this -1. There's nothing in the other equation here that I've created to line up with just a numerical value, so it's just blank. So now, just like you used to do problems like 2 + 1 = 3, I'm just going to visualize the same thing here. What I'm doing is I'm just adding together these columns that all contain like terms. So this isn't a division sign, by the way. I'm just representing an equal sign like you used to do in elementary school, perhaps. So a -6x and a +6x, remember, if you don't see a sign, it's a positive. That makes 0, and that was our goal. That's why we doubled this equation to make it a -6, so that combined with 6x would make 0. And combining terms in this column, we still just have the -4. Combining a +4y, remember that's a plus, and a -5y makes a -1y. And you could write 1, but you can also just write -y. And then -1. The x's have disappeared. Now all I have left is a y, and so now I can solve this equation. Now, to solve an equation, what I have to do is I have to use PEMDAS, the order of operations, but I have to use it backwards when I solve. So I ask, what's happening to the variable? In this case, y. Is it being subtracted by something? Yes, it is, -1. So I'm going to undo subtraction by using the inverse of subtraction, which is addition. I'm going to add 1. I'm going to do the same to both sides of the equation. And that makes 0. I'm left with just a -y. And on this side, -4 and a +1 make a -3. Okay, so I'm not quite done. I've undone the subtraction. Is it being added by anything? What's happening to y? Is it being added? No. Is it being divided? No. Is y being multiplied by something? Yes. Remember, this is a -1 times y. That's what a -y means. And so I'm going to undo the multiplication that's happening by using the inverse operation of multiplication, which is division. I'm going to divide both sides by -1. And a negative divided by a negative makes a positive, and a 1 divided by 1 makes 1. So that makes +1y. And again, that's just y. Equals, negative divided by a negative is a positive, and 3 divided by 1 is 3. Y equals 3. So I have just found the y coordinate of the point of intersection that two lines would show if you were to graph these two equations. All right, that is the end of this problem. Thank you for watching another video from askmath.com. Don't forget to check out the other videos.